Vectors. Vectors are used when talking about a value that has more than one dimension. So a good example would be spatial dimensions. To describe this point in space here, let's see how far we are. So it'd be about, maybe 2 in the x direction. If that's 2, this will be, let's say, 4 in the y direction. And here in the z, it might be, it's not as high as that, so let's call it 3 in the z direction. 3.5, we'll call it 3.5 in the z direction. So this point in space is considered 2 in the x, 3.5 in the, 4 in the y direction, and 3.5 in the z direction, labeled as x, y, and z. Now, that's a little confusing to describe a point like that. So there's 2 ways of describing this point, or describing this location in space. Type 1, which will be called components, is that you can literally just write down the components. So in the x direction, vector x direction, we will say it is 2 meters. And these are the units of this number. Vector in the y direction, we'll call it 4 meters. And vector in the z direction, we'll call it 3.5 meters. And we literally just write down the numbers and break it down into components. These numbers are called scalars because they don't have any direction. It's just a number. It's just 2 meters. I have to specify the direction here. There's a second way of doing this, and it's called vector format. We'll write it up here. Type 2. And this is the purpose of this video, is to introduce vectors, to describe all this information in one variable, vector, with a line above to indicate to the person who's reading that this number that's about to show up includes more than one dimension. It's not a scalar. It's not an individual number. It both has a number and a direction. So in this case, it will be 2. How do I signify the x direction? Let's do x hat. This indicates the x direction unit vector plus 4 y hat plus 3.5 z hat. People have also used I hat, j hat, and k hat. They also are in line in the alphabet, just like x, y, z, I, j, k. I find it confusing. I like to put the x's, y's in here with the little hat. All it signifies is a unit vector in that direction. So it says that this vector here, vector, we could call it 1, vector 1, is equal to 2 in the x direction, plus 4 in the y direction, plus 3.5 in the z direction. And this whole thing here is called a vector, because it not only has a numerical value of how far it goes, but it also has the direction as well, indicated by this top little hat here. If I wanted to know the actual distance, what's the actual distance of that? Well, I would use Pythagoras Theorem here. And there's another notation right here to show this. This means magnitude. The magnitude of V1. And this would be just the square root of the x direction, Vx squared, plus Vy squared, plus Vz squared. Now, you can see that I've used both notation here, because this value here is still called Vx. It's still the component. So you can interchange these two components, and we will do that from time to time, is interchange these two components. This section here is the Vy component. And if you wanted to be so specific, it would be the Vx1 component, because this is the first vector. And this would be Vy2. So if I wanted to be so specific here, as I should be, it'd be like this. And that would be proper notation for that. And to actually do the number of it, it would be, so this would be 2 squared plus 4 squared plus 3.5 squared. 5.68. And we have no units for this. It was given in meters, so we could say meters. And this would be the magnitude of vector 1. Now, giving this number by itself would be nothing because it is a scalar. It is a scalar value. The magnitude of a vector will give you a scalar value, and it doesn't tell you what direction it is. All it tells you is how far it is, but it does not tell you the direction. To get the direction, you need to indicate your value in vector format or in components, type 1 or type 2.